Good morning, friends. Today we see the next process. In last lecture, I am discussing the isobaric process. Okay, before starting the new process, isobaric process. Okay, we just go through these 5 formulas. I already discussed in previous lecture also. Okay, if we see here, the general gas equation P1 V1 upon T1 is equal to P2 V2 upon T2. The work done, it is a product of P into change in volume. Change in internal energy is same, mcv delta T. Heat supplied, it is the algebraic sum of change in internal energy plus work done, and that's two formulas that previously we calculated. Just we going to summation of these two formulas, that is heat supplied and the change in enthalpy. It is algebraic sum of internal energy and flow work. Also we going to take the new formula. Also there is a entropy, okay, which is needed in the new third topic. So let's start with the isobaric process. In isobaric process, if we see in isobaric process, isobaric process are done. Okay, today we see the isobaric process. In isobaric process, if we see baric, the bar is, if is known that you measure the pressure in bar, the bar stands for pressure, the constant pressure process. Okay, if we see the isobaric process, last time also we discussed, this line is perpendicular to that pressure axis, that is 1 to 2. Suppose the process is going on, the state change from 1 to 2, that is isobaric process on PV. On TS, if we see, when going to add the heat, okay, the temperature as well as entropy is going to increase from 1 to 2 on a TS diagram. And also we call that the area under PV diagram, which indicates, always remember, area under PV diagram which indicates work done or work done by the system. The area under TS diagram which indicates what amount of heat is supplied or rejected by the system. These two areas we use the values on a graph. So let's start with the isobaric process. Last time you see the isochoric process. I just revised in short. In isochoric process, there is no change in volume. Volume is a constant. So general formula is what amount of heat is supplied is generally used for the two purpose. First is internal energy and work done. In case of isochoric process, there is no work done because there is no change in volume. So what amount of energy we applied is utilized for increasing its internal energy. So dq is equal to du is equal to mcv delta T. The last time also we discussed. Okay, today starts with the isobaric process. Okay, boiling up water in open vessel. This is a general example we see in day-to-day life, that is the isobaric process. Okay, now we see on the PV diagram isobaric process. Suppose work is done. If you suppose here process 1 to 2, okay, work is happen because of some heat is going to add. Okay, if you assume, suppose initial volume is V1, and if you adding heat, the heat added in the system is a positive. Okay, that process I am going to show on the PV diagram. What amount of heat is going to add, the volume is goes on increases. The final volume is, suppose initial volume is V1, and after addition of heat, it get final volume is, suppose it is the Vf, or that is the V2. There is a change in volume. If you see on that PV diagram 1 to 2, if addition of it takes place, is work done by the system. We get some mechanical movement, we get some reciprocating motion, upward movement, that is the work done by the system, is called as a positive. If we see the piston moves upward, okay, and if we stop the removing the heat, that is the in reverse direction. If system starts or stopping the supplying heat, what happen? The heat is rejected by the system. What happen on the time the piston moves in downward direction? Okay, in that case work is done on the system, so work is negative. That whole process I am showing on the PV diagram. Now what is meant by isobaric process? The expansion and the compression of the piston is carried out at constant pressure. Means what means a constant pressure? If we see the mass maintain a constant pressure in the cylinder. At under constant load, it move upward. At constant load, it moves downward direction. So load on the system throughout process during compression, during expansion is same. Such kind of process we called as a isobaric process. Now we see one example we observe in day-to-day life also. This is very interesting. You also this demo we can made in home also and feel that magic. Just see this video. Piece of one nail, okay, blow up the balloon. We just mountain the number of nail on that wooden board. If you observe, balloon is the single balloon is there, and we put on the single nail is easily blast. So what happened when you apply pressure on number of nail? What happened about the balloon? See what is the magic. See here what happened. Still balloon is not blast. When applying force on the number of nails, when applying single nail, it easily blast. But what happened? Okay, because see here what happened. The force is distributed over a large area. Okay. What in previous case the load is concentrated on the single area. Now that whole process is distributed on a large area. We know that fundamental formula of the pressure is equal to, okay, that large area, force upon area, okay, pressure is nothing but area is going on increases. In that case area is going on increases. What about pressure is goes on decreases. So the balloon can't blast. Okay, when you press a balloon onto one nail, all the pressure from that nail is concentrated on one small area of the balloon, which results in the balloons bursting. When you press a balloon on many nails, it does not burst because the pressure is diffused or distributed over a large area. Okay, now see the actual isobaric process. If you observe here, what are the changes on PV diagram? What about temperature? What about volume? If you see this animation, we can easily observe the different parameters. What about pressure? What about volume? What about temperature? Okay, when we add the heat, if you see here, what about temperature goes on increases. What about volume? If you see volume goes on increases, and the pressure is keeping constant. So isobaric process pressure is a constant. So the initial pressure is equal to final pressure. P1 is equal to P2. Under constant pressure, it gives work. The volume goes on increases and temperature also goes on increases. This is the isobaric process. Now we start with the expressions or the derivations, small derivations. Those are the basic 5 formulas I am going to apply in the isobaric process, and what's the result. These are the derivations asked in the many exams. Okay, so carefully take the screenshot of this image so it is helpful to understand. Okay, first the general gas equation, that is a P1 V1 upon T1 is equal to P2 V2 upon T2. In that case pressure is a constant, so P1 is equal to P2. What happened for the general gas equation for isobaric process? Now V1 upon T1 is equal to V2 upon T2. In case of isobaric process, what happened? Volume is a constant and the general gas equation becomes P1 upon T1 is equal to P2 upon T2. In case of isobaric, here pressure is a constant, so V1 upon T1 is equal to V2 upon T2. Then you apply next formula. Work done by the gas. Fundamental formula dW is equal to P into dV. Here in case of isobaric, volume is a constant, so work done becomes 0. But here at constant pressure system gives work the change in volume. So P is into V2 minus V1. And we know that PV is equal to MRT. So that PV2 is equal to MRT2. Here equation becomes MRT2 minus MRT1. MR is constant. So MR in bracket T2 minus T1. So it is the work done. In case of isobaric, work done is equal to MR in bracket T2 minus T1. Now in case of change in internal energy is the same for isobaric also, that is mCV delta T. Is similar for isochoric, it is similar for isothermal, it is similar for isentropic or adiabatic process. Then heat supplied, I told that heat supplied is nothing but it is the addition of previous two formulas, that is internal energy and work done. So internal energy is mCV delta T and work done is MR T2 minus T1. Okay, if you removing the common, that is the M T2 minus T1 in bracket CV plus R. So we know the relation Cp minus Cv is equal to R. Here Cv plus R, what we get relation, that is the Cp. Okay, we need relation like that. Cp is equal to R plus Cv. The fundamental equation, we know that Cp minus Cv is equal to R. Here the relation we need Cv plus R. Okay, this is nothing but is equal to Cp. So heat supplied is equal to mCp delta T. We're just going to add these two previous equations and then going to apply the change in enthalpy. Enthalpy is nothing but algebraic sum of internal energy and flow work. Okay, if we going to solve is similar to the previous isochoric equation, then du is equal to mCv delta T, that change in internal is equal to again MR T2 minus T1, and the same equation becomes, so I am directly written here the same directly equation of the change in enthalpy, mCp delta T. Okay, now the change in entropy. What about change in entropy? Simply we take integral of dq by T for process, for which process we are going to apply. Now we apply the change in entropy for isobaric, so take directly dq of isobaric process. We calculate here mCp delta T. For unit mass, it is Cp dt by T. Cp is a constant and we know that integral of dt by T, it is the log E. So Cp log to the base E T2 minus T1. This is a change in entropy. Just see that right column and summarize this formula for isobaric general gas equation. V1 upon T1 is equal to V2 upon T2. Then work done, simply P V2 minus V1 or MR T2 minus T1. These two formulas need for solving the numerical. Okay, if the volume is given, we can calculate work done. If that volume is not given, if they given both temperature and they given the characteristics gas constant R, so we can also calculate the work done. Just so remember these fundamental formulas. Then change in internal energy. If you see here, the change in internal energy and the change in enthalpy is the same for both process, isochoric and isobaric process. The only change is heat supplied. If you remember the previous video or previous lecture, heat supplied at isochoric or constant volume process, the formula is mCv delta T. The only change is that for isobaric, Cv is replaced by Cp. Is very important. Just remember, simple change is here. Heat added at constant pressure, we just remember formula mCp delta T. And in case of isochoric process, it is the mCv delta T. These are the only same change, and the du and dh is the same for both process. In isochoric, work done is 0. Here some work is done happen because the volume is going to change. You remember such a formulas or the process, so can exam numericals are simple. Just we remember the formulas. If we confuse in the formula, so it is very difficult. So it is the isobaric process. Hopes you understood these derivations for the isobaric process.